So we are solving the second example of big M method, but this is something different. So we have come up with the formulation of LPP. First we formulate the LPP, then we solve that LPP. So let us see whether this problem can be solved by big M method or simplex method or not. First of all, we first formulate the LPP, then think over it which method can be applied. Fine. So according to this problem, food X contains 6 units of vitamin A. How much? 6 units of vitamin A and 7 units of vitamin B. Fine. 6 units of vitamin A. So A is how much? 6 units. B is how much? 6 units of vitamin A and 7 units of vitamin B. And cost how much? Cost 12 paisa per gram. How much per gram? Fine. Next, food Y contains, this is what? X and this is Y. Food Y contains how much units? 8 units of A and 12 units of B. And cost, how much cost? Cost 20 paisa per gram. Fine. So the daily minimum requirements condition that is what? A is how much? A and B how much? 100 units. I mean to say A is 100 units and B is how much? 120 units respectively. So what we need to find? Find the minimum cost of production mix by simplex method. So once we need to formulate the LPP solution. So let me write once again. Let x1 and x2 be the grams of food X and Y to be purchased. Then min Z is equal to, because find the minimum cost of product mix. So min Z is equal to what it is? 12 x1 plus 20 x2. So 12 x1, that is 12 x1 cost, because cost is to be minimized. 12 x1 plus 20 x2 is equal subjected to 6 x1 plus 8 x2 should be greater than or equal to 100. Next one, 7 x1 plus 12 x2 should be greater than or equal to 120. This is what our objective function. So it is what? Objective function. Fine. By looking into this objective function, we can see that both the constraints are subjected to what? By looking into this equation, both the constraints are subjected to greater than or equal to. So when the constraints are greater than or equal to, we are supposed to go to the big M method. Fine. So by adding slash variables S1 and S2, by adding slack slash surplus variables S1 and S2, the LPP is reformulated. The LPP is reformulated as how? That is min Z is equal to max of minus Z is equal to minus 12 x1 minus 20 x2 plus 0 s1 plus 0 s2 minus m a1 minus m a2. So minimization, what is the first step in the simplex method? If the objective function is minimization, then convert it into maximization. Fine. So we have converted this minimization to maximization. That's why it is minus 12 x1 minus 20 x2, 0 s1, 0 s2. These are the what? Slack variables. Then we are introducing a big penalty, m minus m a1. Why it is minus? Because maximization. If it is maximization, we need to introduce minus m. If it is minimization, we need to introduce plus m. But in this case, we are introducing minus m here. So minus m a1 minus m a2. So this is what our objective function, which is in standard form, subjected to constraints. That is 6 x1 plus 8 x2 plus, that is minus s1 plus a1 is equal to how much? 100. The same thing, 7 x1 plus 12 x2 minus s2 plus a2 is equal to 120. Whereas and x1 comma x2 comma s1 comma s2 all greater than equal to 0. Now this LPP is in standard form. So this standard form of the LPP now can be solved using simplex method. Fine. Earlier this problem was not in a standard form because all the constraints are subjected to greater than equal to. We cannot solve this problem by using simplex method because it is not in standard form. So we need to introduce a slack and surface variables such that the LPP is reformulated as min of z is equal to max of minus z, then minus 12 x1 minus 20 x2 plus 0 s1 plus I mean to say 0 s1 plus 0 s2 minus m a1 minus m a2. These are all slack variables. S1 and S2 are the slack variables, whereas minus m a1 minus m a2, where minus m is the penalty, whereas a1 and a2 are artificial variables. Fine. So then subjected to constraint 6x1 plus 8x2 minus s1 plus a1 is equal to 100, 7x1 plus 12x2 plus s2 plus a2 is 120. So this complete LPP is in standard form. Once it is done, we need to solve the same problem by using simplex method. So that will be explained in the next section.